Let's try this one here. So we end up with 3x squared plus 6x plus 1 equals 0, and it asks me to use the quadratic formula to solve this. In order to have some more space, I'm just going to erase this from here, and you can write smaller on this side here. But if I take a look at this, I'm going to have to use this, the quadratic formula. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And of course, in this one, my a value is 3, my b value is positive 6, and my c value is 1. So continuing this is x equals negative, and then b is 6, plus or minus the square root of b is 6 squared, minus 4 times a is 3 times c is 1, all over 2 times a, which is 3. Continuing this, x equals negative 6 plus or minus the square root of 6 squared is 36, negative 4 times 3 times 1 is negative 12, all over 2 times 3, which is 6. Continuing that, this is x equals negative 6 plus or minus the square root of, now 36 minus 12, 24, 14. Right? 14, no, 24. Sorry, all over 6. Now, it's very important to understand that you can't take the square root of 24. So, when you go to break this up, you can actually, before breaking it up, you have to reduce this. So, this ends up being negative 6 plus or minus all over 6. 24 can be broken up from section 3.4. We're not going to write down, 24 is 4.8 or 4.9 or whatever it is. We're going to actually figure out the real answer, and the real answer, breaking up 24, you have 1 times 24, there's 2 times 12, there's 3 times 8, there's 4 times 6. This is the one you should break it up into, because that's the only one where you can take the square root of a whole number. So I'm going to break this up into root 4 times root 6. So breaking that up, I'm going to end up with negative 6 plus or minus. The square root of 4 is actually 2 all over root 6. Sorry, 2 root 6 all over 6. Now, this is the trick. You can actually reduce this whole fraction. See, every single number in this fraction, I can divide every single number by 2. It's very important that when you go to reduce something, that you are able to reduce every single number by the same number. I can divide every single thing here by 2. So if I divide every single thing by 2, this divided by 2 is negative 3, plus or minus that divided by 2 is just 1 root 6, and then 6 divided by 6 is 3. So this is the most reduced form of that now. Now the two answers, breaking this up, the two answers, the one answer is x equals negative 3 plus root 6 all over 3. That's the one answer, one x-intercept. And the other x-intercept is negative 3 minus root 6 all over 3. This is the second x-intercept. Now, it didn't ask us for approximation, it just said solve, so we leave it as this. Now, if it asks us for an approximation to the nearest tenth, then of course we do the math here and do negative 3 plus root 6 and divide that by 3, whatever that is, that's what we write. But for the purposes of this right now, we leave this as this. What does this also mean? If underneath the square root sign is a number that is positive, but a number you can't take the square root of, what this means is if you tried to factor this at the start, you wouldn't be able to factor it. This would be impossible to do with factoring. You would have to use the quadratic formula. Okay? So these are the two answers here. So that's why you learned the radicals and how to reduce radicals and all that stuff, and so that you'd be able to reduce the radicals here in the quadratic formula. Now there's other scenarios, and I just want to talk about those other scenarios before we get to the last example. You may end up with a scenario that looks like this. So let's say it asks you to use the quadratic formula, and I just want to talk about these scenarios first, because you're going to end up doing this in your homework, and you're going to ask me, what happens when. So let's just take a look. It's a little bit of foreshadowing here too, because there's a whole section on this. But let's say you start doing all this math, okay? And you end up with some negative number out here. I won't write down what the number is, but in here, actually I will write down the number. Let's say you end up over here, negative 4, and this is all over, this ends up being, I don't know, 5, okay? Not 5, 6 or something like that. Okay, and underneath the square root sign, let's say you end up with a 0. Because this could happen. You may do one of the problems where the numbers inside the square roots end up being exactly 0. So far what we've dealt with are underneath the square root sign, you ended up with a 64. And you know that you had 2 solutions, or 2 x-intercepts. When you ended up with a 24 under the square root sign, you also ended up with 2 solutions. What were the difference between the 2 solutions? When it was 64, you ended up with 2 nice solutions where you could have factored. This one were not nice. Those were decimal answers where you couldn't have factored. Now, what happens if you end up with something that looks like this, where you have a 0 under here? Well, let's see what happens and carry on just from here. So this could happen where underneath the square root sign is 0, some other example. And when you do this, what you do is you actually have to go and take the square root of 0. But what's the square root of 0? It's just 0 all over 6. Okay, and then when you break this up into 2 solutions, you're going to have x equals negative 4 plus 0 over 6, or you're going to have x equals negative 4 minus 0 all over 6. Well, what's the difference? Really, there is no difference. Over here, negative 4 plus 0, you get negative 4 over 6, which you can reduce. I won't reduce it. And over here, you'll get negative 4 minus 0, which is still negative 4 all over 6, which you can reduce to the exact same number. So when you have a 0 underneath the square root sign, you will have 2 of the exact same answer. You will have only 1 solution, or 1 x-intercept, which means that the vertex is the x-intercept, which means you also could have solved that using factoring, because we had one problem that looked like that. The other scenario you could end up with, is, let's say you're using your quadratic formula. I'm just writing this again for practice so that I know my quadratic formula for my quiz and test. But let's say you ended up with something like this. I don't know, negative 18 plus or minus the square root of, and inside this bracket, okay, all over, let's say, it ends up being 10 on the bottom. Let's say inside of this bracket you did the multiplication and the addition, all that, and you end up with negative 90. I don't know, just made it up. Well, when you go to do the next line here, what is the square root of negative 9? Please don't tell me negative 3, because negative 3 times negative 3 is not negative 9. Don't tell me 3, because 3 times 3 is not negative 9. It is impossible to take the square root of a negative number. So if you end up with a negative number underneath the square root sign, it is impossible to solve this. If it's impossible, that means there are no x-intercepts. So if you ended up with a negative number under there are 0 solutions. That just means, just like I spoke about at the beginning, you may have a vertex above the x-axis and it opens up, or a vertex below the x-axis and it opens down, so it would never cross the x-axis.